All right, good morning. We have two examples on last week that we did not go through that I want to show you. And then hopefully for the rest of the hour today you're going to have some work time, so please use your time wisely. Please make good choices. All right, so first of all we have y is equal to log base 2/3 of x. Okay, when we're graphing a log function, we always know that our asymptote is the y-axis. So the first thing I'm going to do is on the y-axis, I'm going to put that dashed line for my asymptote. All right, so I have that asymptote on the y-axis, and then because I'm in base log 2/3, I realize that when I make my xy table, I'm going to pick 2/3 to our normal powers, because normally, typically, for our x values, we pick -2, -1, 0, 1, and 2. But that means that I'm going to pick 2/3 to the -2 power, 2/3 to the -1 power, 2/3 to the 0 power, 2/3 to the first, and 2/3 to the second. All right, so as I begin to look at my y values, I have log base 2/3 of 2/3 to the -2 power. We know that whenever the base of my log matches the base of my exponent, they're going to cancel, and my exponent is -2. Keep in mind, when you're finding a logarithm, you are finding an exponent. So we have log base 2/3 of 2/3 to the -1. The base of my log matches the base of my exponent. They're going to cancel. I get -1. Log base 2/3 of 2/3 to the 0. Once again, the base of my log matches the base of my exponent, so they cancel. They're inverse functions, so my exponent is 0. Log base 2/3 of 2/3 to the first. Base of my log matches the base of my exponent, so my exponent is 1. When you're finding a logarithm, you are finding an exponent. And finally, log base 2/3 of 2/3 squared. Base of my log matches the base of my exponent, so they are inverse functions, they cancel, and my exponent is 2. All right, next thing I need to do is I need to go actually back and find what my y values are. So 2/3 squared, 2/3 times 2/3 is 4 ninths, 2/3 to the first is 2/3. And 2/3 to the 0, anything to the 0 is 1. 2/3 to the -1, my negative exponent is going to flip that fraction, so it's 3/2. And 2/3 to the -2, well, 2/3 to a negative power is going to flip that exponent, flip that fraction, so 3/2. 3/2 squared, well, 3 times 3 is 9, and 2 times 2 is 4. Okay, now I need to go and plot my points on my graph. So, plotting my easiest ones first, 1, 0. I'm going to go to the right one. All right, 2/3 1, I'm going to go to the right 2/3 and up 1. 4/9 2, just to the right 4/9, and then up 2. 3/2, so 1 1/2, I'm down 1. 9/4 at 2 1/4, I'm down 2. So notice with this base of 2/3, my log function, as it goes down and to the right, goes away from that asymptote. As it goes up and to the left, it's going to approach that y-axis. So for my asymptote, we always know that for every log function, my asymptote is the y-axis, which means the equation of that line, we're thinking Vux is x equals 0. Domain for my log functions, my x values are to the right of 0, so that's going to be x values are greater than 0, and my range values are going to be all of the y's, so all real numbers. All right, one more example. All right, just one more example. We need to take a look and think about what that h and that k value does. Remembering, I'm now looking at y is equal to log base b of x minus h plus k. All right, we're in any base here, but once again, we realize this shouldn't be too challenging for us. X minus h, it's always the opposite of what's with my x. That shifts it left and right. And my k value is a shift up and down. So, once again, just like we did with our exponential functions, I want you to graph your base function for your parent function first, and then we're going to do the shift. So my parent function is always everything through my x. So if I look at my parent function here, my parent function is going to be everything through my x, so that's y is equal to log base 3 of x. All right, as I begin with my XY table, because I'm in the base of 3, that means I'm going to take 3 to my powers. So I'm going to take 3 to that -2, 3 to that -1, 3 to the 0, 3 to the first, and 3 squared. All right, so as I look at log base 3 of x, my first value for x is 3 to the -2. So that's going to be log base 3 of 3 to the -2. Once again, that same pattern. Whenever the base of my log matches the base of my exponent, they are inverse functions. They undo each other. They cancel. When I'm finding a log, I'm finding an exponent, and my exponent is -2. So the second one is log base 3 of 3 to the -1. Base of my log matches the base of my exponent. They're going to cancel, and my exponent's -1. Log base 3 of 3 to the 0. Base of my log matches the base of my exponent is 0. Log base 3 of 3 to the first. Base of my log matches the base of my exponent, and my exponent is 1. And finally, log base 3 of 3 to the second. Base of my log matches the base of my exponent, and my exponent's 2. Always need to go back and find out what my x values are. I like to start at the bottom because they're nicest. So 3 squared is 9, 3 to the first is 3, anything to the 0 is 1, 3 to the -1 is 1/3, 3 to the -2, all right, 3 to the negative exponent is going to be a third, 1/3 squared, a third times a third is a ninth. All right, so as we begin to look at our graph, every log function, the parent function of every log function, has an asymptote at the y-axis. So I'm going to put that y-axis for my asymptote. 1/9, I'm at -2. Hard to fit that on there. A ninth, I'm at -2. A third, I'm at -1. 1, 0, so I'm to the right 1. 3, 1, I'm to the right 3, up 1. And 9, 2, I'm to the right 9, up 2. All right. So my graph's going to go up and to the right. You don't have to worry about the afternoon.
I know.
All right. So if I look at y is equal to log base 3 of x minus 2 plus 4, if I look at shifting that graph, this is going to go to the right 2, and this is going to go up 4. So the first thing I want to move, first thing I always want to move is my asymptote, my guide for that graph. Right 4 up 2, the up 4 isn't going to do anything, but the right 2 is going to take that asymptote to the right 2. So my vertical asymptote is going to be at x is equal to 2. Then simply take every point, shift it right 2 and up 4. So right 2, up 4, a little bit off the graph, right 2, up 4, right 2, up 4, and that graph is going to approach as it approaches that vertical asymptote to -infinity. My domain, all of my x values are to the right of that vertical line at 2, so x is greater than 2, and my range value is all of my y values, so my range for any log function is always going to be all reals.